Okay, let's unpack this. You've seen the headlines, maybe even lived through some of it yourself. These climate events, they're not just happening, right? They feel more intense, more unpredictable.
Yeah, exactly. Devastating floods, stronger hurricanes, tropical cyclones. It feels like the baseline is shifting.
It really does, and it makes one thing incredibly clear. We need faster, better ways to see what's coming. Forecasting needs to keep up.
Absolutely. Which leads us perfectly into what we're diving into today.
Right. Researchers have developed this, well, pretty remarkable new AI model. They're calling it Aurora.
Mm-hmm.
And we've got a bunch of source material here, including a really interesting paper from Nature to figure out, what is Aurora? How does it actually work?
And what does it mean for us, for forecasting the planet's future?
Exactly. So think of this as our deep dive. We're aiming to cut through the noise and really get to the core of this potential breakthrough.
Yeah, we'll look at the problem it's trying to solve first, then get into the tech, the AI part.
See how it actually performs the numbers?
Yeah, right, the metrics. And then zoom out a bit, look at why this could be such a game changer. Not just for scientists, but for people on the ground.
Okay, so let's start there. The problem. Our sources are pretty clear about the limits of, let's call them traditional forecasting methods. What are they really up against?
Well, the thing to grasp is that for decades, forecasting has relied on these incredibly complex numerical models.
Okay.
They're built on physics, you
Right.
know,
Yeah.
trying to simulate the entire Earth system, atmosphere, oceans, land.
Sounds complicated.
Oh, hugely. They're powerful, don't get me wrong.
Yeah.
But they demand massive supercomputers, like building-sized computers running constantly.
Wow.
And you need large teams of highly specialized experts just to run them, tweak them, interpret what comes out. It's a monumental effort.
Right. It sounds like something only the biggest institutions, maybe the wealthiest countries, can really manage effectively.
That's largely been the case. And you mentioned the need for speed earlier.
Yeah. Why is rapid, reliable forecasting so critical right now? More than ever, it seems.
Because the climate is more volatile. Things are changing faster. The margin for error is shrinking. So quick, accurate forecasts are just vital. Getting people out of harm's way before a flood, deploying emergency help efficiently, adapting infrastructure.
All depends on knowing what's coming.
Exactly. And those traditional methods, while foundational, they can be slow, expensive to run.
Yeah.
Which limits how often you can run them or the detail you can get for specific areas.
Which sets the stage perfectly for Aurora. The sources frame this as using AI for a smarter, maybe more efficient way.
Precisely. The core idea is harnessing state-of-the-art machine learning. One of the key people involved, Max Welling, talks about leveraging the latest AI techniques.
Okay, and the model itself, it's built on what they call a foundation model. What does that actually mean here? I've heard that term, but maybe not for climate science.
Yeah, the good question. Think of it like this. Traditional models try to code the rules of physics explicitly.
Okay.
An AI foundation model, like Aurora's, which has about 1.3 billion parameters. Think of them like adjustable knobs, billions of them. The model learns by looking at vast amounts of data, and it tunes these knobs itself to find patterns, relationships between, say, temperature here and rainfall over there.
Ah, so it learns the patterns from the data rather than being explicitly told the physics rules.
Kind of, yeah.
Yeah.
It learns the language of the Earth system by observing it, finding connections. Maybe even the physics models struggle to capture efficiently. It sees how things actually behave together.
Okay, so it learned by observing. How much data are we talking about? What did it actually see?
A massive amount. They trained it on over 1 million hours of Earth system data.
1 million hours?
Yeah. Weather station readings, satellite images, ocean buoy data, atmospheric chemistry, just a huge, diverse data set. That's what lets it build such a comprehensive picture.
And the major advantage the research highlights is that running it needs far less computer power compared to those traditional giants.
Huge difference. And this is where it gets really interesting for accessibility.
Yeah.
Well, if you don't need a multi-million-dollar supercomputer complex,
Right.
you certainly make top-tier forecasting way more affordable, more scalable.
So you're thinking smaller countries,
Yeah.
maybe regions in the global south that couldn't afford that kind of infrastructure.
Exactly. Or even, smaller weather services, university research groups, maybe city planners focusing on very local flood risk or something.
Places that were previously locked out.
Precisely. Anna Lucic, an AI researcher involved, really points this out. This shift in computational needs. It's incredibly valuable for kind of democratizing forecasting.
Democratizing forecasting. I like that.
It means more communities, especially vulnerable ones, could potentially get access to cutting-edge predictions.
Okay, so efficiency, accessibility, those are big pluses. But the real test is performance, right? How does Aurora actually do? Does it stack up against the established methods?
The numbers they published are, well, they're pretty eye-opening.
Oh, yeah.
The paper details specific areas. Take air quality forecasting. Aurora outperformed the traditional models in nearly 3/4 of the tests, 74%.
74% better on air quality. Wow. Okay, what else? Ocean waves.
Even higher there. It beat the numerical simulations on 86% of the targets they measured.
86%. Okay. And the big one, tropical cyclones. Hurricanes, typhoons, that's critical for safety.
This is maybe the most striking stat they mentioned. In the tests described in the source material, Aurora beat 7 leading operational forecasting centers, 100% of the time.
Wait, 100% against 7 operational centers?
100%. Beating the top centers every single time in those specific tests for something as complex as cyclone tracks.
Yeah.
That's a significant result.
That's not just significant, that's kind of staggering. And just general high-resolution weather forecasts.
Surpassed the leading models in 92% of scenarios tested.
92.
And here's a really key point. It did particularly well during extreme events.
When you need it most.
Exactly. Those moments when things get chaotic, which can sometimes trip up the traditional models. Aurora seems to handle that complexity remarkably well, according to the paper.
Okay, those performance numbers, especially the 100% on cyclones and doing well in extremes, that really drives home the potential impact.
For sure.
And the sources also mention another angle, the speed of developing these models.
Yes, Anna Lucic notes this too, because it's built on this flexible AI foundation, development cycles that used to take years for traditional models.
Yeah.
Potentially just weeks now, with relatively small engineering teams.
Weeks versus years. That changes the game for innovation, doesn't it? You can iterate so much faster.
It really does speed things up. Yeah. But it's important context, something Max Welling points out.
Okay.
This speed isn't happening in a vacuum. It's possible because it's building on decades of foundational climate science research.
Right.
And crucially, it relies on those immense data sets that the traditional methods and observing systems have painstakingly collected over all those years.
So it's like a faster car, but it still needs the roads and the fuel that were already there?
That's a great analogy. Exactly. Yeah. It's an acceleration built on a robust, pre-existing infrastructure of data and knowledge.
Got it. So this powerful, efficient, rapidly developing model, is it locked away in a lab somewhere?
No, and this is another really key aspect. According to the sources, Aurora is being made available freely online. Anyone can use it.
Freely available. That's huge. For researchers, students, maybe even businesses or NGOs trying to understand local climate risks?
Potentially, yeah.
What if you wanted to use it for something really specific, like predicting flood risk just for one particular river valley? Does the free version do that?
So Anna Lucic clarifies this. The base model is trained on that huge global data set. If you want to fine-tune it for a super specific task like that, you would need to provide it with data relevant to that task. Historical flood data for that valley, local terrain details, that sort of thing.
Okay, so you add local knowledge.
Exactly. Yeah. But the crucial thing is you don't need to redo that massive initial training. The foundational knowledge, the understanding of how weather systems generally work, is already baked into the model you download. You're starting with a really smart base.
That sounds incredibly flexible, powerful for all sorts of applications.
It really is. Max Welling highlights its ability to handle diverse data types. That makes it very versatile and kind of future-ready for new data sources, too.
And looking ahead, the sources actually list a whole range of things this could be used for, beyond just standard weather or air quality.
Right. They toss out ideas like forecasting very localized flood risks, tracking wildfire spread in near real time.
Wildfires, yeah.
Crucial, predicting seasonal weather trends, which is huge for agriculture, or even things like forecasting agricultural yields or predicting renewable energy output, how much wind or solar power you might generate tomorrow or next week.
Wow, the potential uses just stretch across so many sectors that depend on environmental conditions.
It really touches a lot of areas.
So, if we zoom out again, think about the bigger picture. What does a tool like Aurora represent for how we deal with climate challenges overall?
Well, what the sources suggest is this could be part of a fundamental shift, away from just reacting to disasters after they happen.
The cleanup and rebuild cycle.
Exactly.
Yeah.
Towards something much more proactive. Models like Aurora, with their speed, accuracy, and this newfound accessibility, they could really empower a move towards building genuine climate resilience.
Proactive resilience.
Yeah, helping communities, nations prepare more effectively, tackle climate change challenges with much better, faster information at their fingertips. The source material definitely hints at that kind of paradigm shift.
That feels like a critical change we desperately need right now.
It does.
So, recapping. Faster, more accurate, more affordable forecasting. Across weather, air quality, maybe much more soon. Driven by AI and, crucially, accessible to many more people around the globe. That really seems to be the core promise here, based on these sources.
It definitely offers a powerful glimpse into a future where perhaps advanced environmental intelligence isn't quite as limited by geography or budget as it has been historically.
Okay, so considering all that Aurora's capabilities, the fact that this kind of power is becoming freely available online, it really makes you think, doesn't it? How might having access to incredibly precise forecasts for weather, air quality, maybe flood risks next week, how might that fundamentally change things, not just for governments or big companies, but for you, your daily decisions, long-term plans, maybe even how countries cooperate in a world that's clearly facing a more volatile climate?
Something to definitely mull over as you navigate your own corner of the planet.